A very good morning, good afternoon, good evening to my dear students. Today I am going to explain the chapter Inverse Trigonometric Functions. So before starting my lecture, I want you all to keep two things in your mind. First is you have to be tension free throughout the lecture. Listen, with a mind full of worries and tensions, you can't understand even the simplest or the easiest question. So clear all the worries and tension from your mind. And second is you have to be attentive, be focused throughout the lecture. So let's begin. So first of all, I will explain you what is an invertible function. See, an invertible function is a function which is both 1 and onto. Means the inverse of a function exists if and only if it is both 1 and onto. So let's come to inverse trigonometric functions. So what are trigonometric functions? They are sine x, cos x, tan x, cot x, etc. So inverse trigonometric functions, let's take up inverse sine function. So y is equal to sine x. This is simply sine function. So inverse of sine function is written as sine inverse y is equal to x. Similarly, inverse of cos function is written as cos inverse y is equal to x. Cot inverse y is equal to x, and so on. So the trigonometric functions are not 1 and onto throughout their natural domains and ranges. Therefore, we put certain restrictions on the domains and ranges of the trigonometric functions so that in these restricted domains and ranges, the trigonometric functions are both 1 and onto, and that's why their inverse exists. So before coming to the restricted domains and ranges of trigonometric functions, first I will explain you what is the actual meaning of a domain and a range. Because many students have confusion in this, therefore I am taking up this first. So let this set be called domain and this be called the range. And here I have taken up the function sine inverse y is equal to x. The sine inverse y is equal to x. So what is domain? Domain is the set of all the possible values of y which will make this function sine inverse y defined. Are you getting what I am saying? The set of all the possible values of y which will make this function defined, is called the domain. And what is the range? See, for each different value of y, we will get a different value of x. That means a different value of this function. So that the set of all the possible values of this function, that means the set of all the possible values of x is said to be the range. So what is domain? The set of all the possible values of y, and range is the set of all the possible values of x. So I think that you have got what I am explaining. So let's come to the restricted domains and ranges of trigonometric functions. Means in this domain and in this range, the trigonometric functions are invertible. They are both 1 and onto. So first we will take up the inverse sine function. The domain of sine inverse function is -1 to 1. So what is domain? Domain is here y is equal to sine inverse x. So domain is all the set of all the possible values of x. So it is from -1 to 1. So we can take any value from -1 to 1, means -1, then -0.9, -0.8, then 0, then 0.1 to 1. So in between -1 to 1, all the values if we put any value in place of x, we will get a defined value of this function. Then, what is the range? So here the range is also called the principal value. The range of this function is from minus pi by 2 to plus pi by 2. Means any value between minus pi by 2 to plus pi by 2, including minus pi by 2 and plus pi by 2, it is called the range of sine inverse function. Similarly, for cos inverse function, the domain is from minus 1 to 1, same as for sine inverse function, and the range is 0 to pi. For tan inverse function, the domain is the set of all the real numbers. R stands for the set of all the real numbers. Means in place of x, we can put any real number. And then we will get a defined value, a definite value of this function, tan inverse x. And what is the range of tan inverse function? It is from minus pi by 2 to plus pi by 2. But can you see any difference between the range of tan inverse function and the range of sine inverse function? Yes, there is a difference. See, in case of sine inverse function, we have the bracket as the square bracket. So, square bracket represents the closed interval, means the endpoints of this interval are also included, means minus pi by 2 and plus pi by 2 are also included. And in case of tan inverse function, we have the round bracket. That is, round bracket represents a open interval, means the endpoints are not included. Value between minus pi by 2 to plus pi by 2 except minus pi by 2 and pi by 2 is said to be the range of tan inverse function. Similarly, for cosec inverse x, we have the domain as r minus 1 to plus 1. See, it is written as like this. So many students have difficulty in understanding what this stands for. The endpoints minus 1 and 1 are not included. So what is it? It means that the set of all the real numbers except those between minus 1 to plus 1 come in the domain of cosec inverse function. So now the range here we have as minus pi by 2 to plus pi by 2 minus 0. Same as this, na? So what does it stands for? It means that we can put any value in between minus pi by 2 to plus pi by 2, including minus pi by 2 and pi by 2, since here also we are having the closed interval, except for 0 in place of x. Since here, in place of y. Here y stands for the range and x for domain. Now, take the sec inverse function. See, the domain of sec inverse function and cosec inverse function are both the same. It is the set of all the real numbers except those between minus 1 to plus 1. Now the range of sec inverse function is 0, pi minus pi by 2. It also stands for, we can take any number from any angle from 0 to pi except for pi by 2. This minus stands for except for. Now cot inverse function, the domain of cot inverse function and tan inverse function is the same. That is the set of all the real numbers. And the range is 0, pi, means the set of all the numbers from 0 to pi except the endpoints. That is except 0 and pi. Since here we are having the open interval, the round bracket. So I hope the domain, the restricted domains and ranges of these inverse trigonometric functions are clear to you all. So let's take up some of the examples. Find the principal value of. So let's do this. First one is sine inverse 1 upon under root 2. So what we have to find? We have to find the principal value, means this one. We have to find the range. We have to find such a value of this function sine inverse 1 upon under root 2 such that it lies in the principal value branch of sine inverse function. So what is the principal value branch? Means you can take any value in between minus pi by 2 to plus pi by 2, and then that value is said to be the principal value. So be careful, you have to find such value of this function so that it lies between minus pi by 2 to plus pi by 2. Since here it is written that you have to find the principal value. So what is the principal value branch of sine inverse function? It is from minus pi by 2 to plus pi by 2. Now, first step is to let the function as y or theta, you can take anything. Then what is the next step? 1 upon root 2. You take sine inverse from LHS to RHS, so it becomes sine y. Now 1 upon root 2 here we have. So what should be the value of y? It could be pi by 4, 45 degree, sine 45. What is here y? Y is the principal value. You have to find the principal value of this function now. So the value of y must lie between minus pi by 2 to plus pi by 2. So here you are getting that y is equal to pi by 4. So does pi by 4 lies in the principal value branch of sine inverse function? Yes, it does lies. Therefore, you can write y as pi by 4, since pi by 4 belongs to minus pi by 2 to plus pi by 2. Now take up the next question. If you have any problem regarding any question, just mention it in the comment box. Again, first of all, we will write the principal value branch of cosec inverse function. So what is the principal value branch of cosec inverse function? It is from minus pi by 2 to plus pi by 2 minus 0. So next is, let this function as y, then 2 is equal to cosec y. Then when we have cosec as 2, for which value of y? Just remember cosec y, it is cosec pi upon 6. So can you write y is equal to pi by 6? First you have to check that whether pi by 6 lies in the principal value branch or not, because y here is the principal value. So pi by 6 is 30 degree. So it lies, it does lies. Therefore again you can write y is equal to pi by 6. Why? Because it does belongs to the principal value branch minus pi by 2 to plus pi by 2 except 0. I hope this one is also clear to you all. Next question is, sine inverse minus under root 3 by 2. Again, first of all, you will write the principal value branch of sine inverse function. So what is it? It is again minus pi by 2 to plus pi by 2. Means you have to find such value of this function so that it lies between minus pi by 2 to plus pi by 2. Then only it is called the principal value. Again you will let it as y. Sine y. Now you have minus under root 3 by 2, isn't it? So under root 3 by 2, you have when sine is under root 3 by 2, when theta is pi by 3. So minus under root 3 by 2 is equal to minus sine pi by 3. So now what you will do here? Here you are getting that minus sine pi by 3 is equal to sine y. But you have to eliminate this negative sign. Then you can write the value of y, since the angle which will come here, that must be equal to y. So here we will use a trigonometric identity. Do you all remember this? Sine of minus x is equal to minus sine x. So here we will make use of the same identity. We have minus sine pi by 3 and we have to eliminate this negative sign. So what will we do? What is the next step? We can write minus sine x is equal to sine of minus x. So now, what are you getting here? You are getting y to be equal to minus pi by 3. So first you will check that whether minus pi by 3 lies in the principal value branch or not. Principal value branch of sine is from minus sine inverse function is from minus pi by 2 to plus pi by 2. So does it lies? Yeah, it does lies. So you can write y as minus pi by 3 since it lies in the principal value branch of sine inverse function. So let's take up the next question. Cos inverse minus 1 by 2. Okay. So again, first what do we have to do? Firstly, we have to remember the principal value branch of this function. That means of cos inverse function. So what is it? It is from 0 to pi. You have to find such value of cos inverse function so that it lies between minus 0 to pi. So, you should be knowing the value of y when we have 1 by 2. Cos what is the value of theta when cos is 1 by 2? So, what is it? It is pi by 3. So, minus 1 by 2 corresponds to minus cos pi by 3. So, what is the next step? Here also you are getting the same thing. Can you link it? See? Cos y is equal to minus cos pi by 3. But here you don't have an identity like this. Why? Because cos of minus x is equal to cos x and not minus cos x. So you can't make use of this identity, but then also I mentioned it because it could be helpful in rest of the questions. Here we make use of the graph system. So what is it? Many of you must be familiar with it. 0, pi by 2, pi, 3 pi by 2 and 2 pi. Here, what do we have to do first? Here also, first of all, you have to keep in mind the principal value branch of the function. So here we have cos inverse function, so its principal value branch is from 0 to pi. 0 to pi. You have to find any value of y. See, here you are getting cos y is equal to minus cos pi by 3. But it should lie between 0 to pi. And cos function is positive in first and the fourth quadrant and negative in second and the third quadrant. So here you are getting the negative value, and the principal value branch includes the first and the second quadrant. So you have to take the value in the second quadrant. So now what is the procedure of calculating this? You can write minus cos pi by 3 as cos pi minus pi by 3. Why? Since see, cos pi minus pi by 3, pi minus something. So you will come in the second quadrant, and ultimately the value of cos will become negative, and it is minus cos pi by 3. This is an identity also. It is cos pi minus x is equal to minus cos of x. All these identities you must have studied in class 11th. So just go through that. So, what is the next step? It is cos 2 pi by 3. What's here? Cos y. So now can you write y has to be equal to 2 pi upon 3? First you have to check that whether 2 pi by 3 lies in the principal value branch or not. So what is the principal value branch? 0 to pi. So it does lies. Therefore you can write y is equal to 2 pi by 3. Because 2 pi by 3 belongs to the principal value branch. Now, just the last question is left, okay? Let's do it patiently, quickly. Cot inverse minus under root 3. Here also, first of all, you have to do is you have to remember the principal value branch of cot inverse function. So what it is? It is from 0 to pi. You have to find such a value of this function such that it lies between 0 to pi. Then only it will be called the principal value. Let the function as y. Next step is to take over the function from LHS to RHS. Then here also you have to do the same thing. Minus root 3 you must not be familiar with it, but root 3 it's very easy. So when it's got root 3, when theta is pi upon 6, so minus under root 3 means minus cot pi by 6. So here also you have the identity here as cot of minus x is equal to minus cot x. But why can't you make use of this identity here? Because if you will do so, then what will you get? You will get cot y is equal to cot minus pi by 6. So can minus pi by 6 be equal to y? No, because minus pi by 6 does not lies in the principal value branch. See, principal value branch includes from 0 to pi, numbers from 0 to pi, and not minus pi by 6. So here also you have to seek for the graph system. This is the graph system for cot inverse function. So here also the thing first of all you have to mention the principal value branch of the function that you are taking up. So it is cot inverse function. It is from 0 to pi, but in this case not including the endpoints. And cot function is positive in the first and the third quadrant and negative in the second and the fourth quadrant. And the principal value branch includes the first and the second quadrant. So you have to find such a value of y so that it lies in the second quadrant, because cot is negative, and principal value branch also includes the second quadrant. So don't be panic, okay? You will soon understand it. What will it be? In place of minus cot pi by 6, you can write cot pi minus pi by 6. See, here also again you have the same thing. Pi minus something means pi minus something. You are coming in the second quadrant. Second quadrant means in between 0 to pi. So the value is the principal value. This is also an identity, dear students. Nothing from out of the book. This from cot pi minus x is equal to minus cot x. Okay, so what were you having just now? Minus cot x minus cot x. So you rewrite it as cot of pi minus x. Cot of pi minus x. This cot 5 pi by 6. Can you write y as equal to 5 by 6? First you have to check that whether 5 pi by 6 comes in the principal value branch or not. So principal value branch is 0 to pi. So it thus includes this number 5 pi by 6. Therefore y is equal to 5 pi by 6 because it belongs to the principal value branch of cot inverse function. So I hope everything is clear to you. Whatever is taught in today's lecture is clear to you all. Just take up the screenshot of the page which you are thinking that it is important to you. Remember students, revision is must. You have to revise each and every question, each and every formula. Okay, otherwise whether you are a genius in maths, then also you can't get 100 out of 100, I think so.
In the end, I wish to share my few words with you all. Never treat a person as a burden, though you find him the most troublesome guy or a ne'er-do-well, because every person comes in your life for a cause and whom you may need urgently at any stage of your life. Okay, take care. Bye-bye.